friendly guide to evaluating research studies. Welcome to this lesson on how to evaluate research studies. Whether you're analyzing scientific papers for class or trying to understand research claims in the news, these skills will help you think critically about any study you encounter. Let's start with identifying a study's purpose. The foundation of any study is why the researchers conducted it in the first place. Look for this core objective in the abstract or introduction. It's the backbone of the research and answers the question, what were they trying to find out? A well-stated purpose is focused and clear. It typically identifies the main variables being studied and the relationships the researchers wanted to explore. When reading a study, this should be your starting point as it frames everything that follows. Now, let's consider how researchers build on previous work. When evaluating a study, check the publication dates of cited sources. A good study typically includes recent sources that reflect current understanding in the field, some foundational or classic sources that establish key concepts, and a range of dates showing thorough coverage of the topic's development. The relevance of dates varies by field. In rapidly evolving areas like technology or medicine, very recent sources are crucial. In more established fields, older foundational works remain important. The key question is, does the research build appropriately on what was already known? Moving on to understanding research claims. Research studies typically make one of three main types of claims. Frequency claims simply state how common something is, like 45% of adults own a pet. They focus on a single variable without connecting it to anything else. Association claims link two variables but don't assert causation. For example, pet ownership is associated with lower stress levels. Words like linked to, correlated with, or tends to signal association claims. Causal claims state that one variable directly causes changes in another. For instance, playing with pets reduces blood pressure. These stronger claims require experimental designs with random assignment. You'll see words like improves, reduces, or leads to in causal claims. The type of claim should match the study design. Correlational studies should make association claims, while true experiments can make causal claims. Watch out for studies that overstate their findings by making causal claims based on correlational designs. Let's discuss research methods and data collection next. Research methods refer to the overall approach used to answer the question. Common methods include experiments, surveys, observations, case studies, and meta-analyses. Data collection is how researchers gather information within their chosen method. This might involve questionnaires or interviews, direct measurements like blood tests or reaction times, observations of behavior, or analysis of existing records or documents. When evaluating a study, ask, is this method appropriate for answering their research question? And was the data collected in a way that minimizes bias and error? Another important aspect to consider is the sample used in the study. A study sample refers to who or what was examined. When evaluating research, consider the sample size, as larger samples generally provide more reliable results. Think about representativeness. Does the sample reflect the population the researchers want to draw conclusions about? Consider the selection method. How were participants chosen? Random selection is often ideal. And don't forget demographics. Age, gender, education, location, and other characteristics might influence findings. Be wary of studies with very small samples or ones where participants all come from limited backgrounds, like college students at one university. These factors limit how broadly we can apply the findings. Now, let's turn our attention to statistical analysis in research. Statistics help researchers make sense of their data. Common analyses include t-tests to compare means between two groups, ANOVA to compare means across multiple groups, correlation to measure relationships between variables, regression to predict values based on relationships between variables, and effect sizes to quantify the strength of relationships. When reading about statistical results, Look for p-values indicating statistical significance, confidence intervals showing the range of likely values, and effect sizes indicating practical importance, not just statistical significance. Remember that statistical significance, typically p less than 0.5, only tells us that results probably didn't happen by chance. It doesn't necessarily mean the findings are important or meaningful in real life. An essential skill in evaluating research is recognizing limitations. No study is perfect, and acknowledging limitations is crucial for honest science. Common limitations include small sample size, where fewer participants mean less reliable results, selection bias, where how participants were recruited might skew findings, measurement issues, where tools used might not accurately capture what they intended to measure, confounding variables that weren't controlled for might explain results, limited generalizability, where findings might apply only to specific populations or contexts, and short duration, where studies conducted over brief periods might miss long-term effects. Good researchers acknowledge these limitations themselves. When they don't, it's up to you as a critical reader to identify them. Finally, let's consider how to apply research to real life. Research should ultimately inform real-world decisions. When considering how to apply findings, ask how strong the evidence is, whether the benefits suggested outweigh potential costs, if the findings are relevant to your specific situation or context, and whether the results have been replicated in other studies. Be cautious about dramatically changing practices based on a single study. The most reliable applications come from consistent findings across multiple well-designed studies. Evaluating research isn't about being skeptical of everything. It's about being thoughtfully critical. By examining each of these components, you can determine when to trust findings and how much weight to give them in your decision-making. These skills don't just apply to academic papers. They help you evaluate research claims in news articles, advertisements, and policy discussions. In a world full of information, these tools help you separate reliable evidence from questionable claims. The more studies you evaluate, the more comfortable and skilled you'll become at this process. Happy researching!